Okay, this is practice 10, number 1 continued, so part 2. So I left off here, we're going to find the p-value, so we have to go to our z-table, so we have to look for negative 1.04 on our table. So let's take a look, so this is the negative 1.04 guy here on our table. So let's click on our table here, enlarge it. Okay, so let's go to the negative side, it's right there. So looking for 1.04. So 1.04. So here's, write this in here. Okay, so so the 1.0 here. I'm going to go over to the 4 column. A little more there. And come down the 0.04. So it'd be 0.1492. Okay, so that's clear. It is 1492. Okay, clear drawing. 1492. Let's go back here now. So this is equal to 0.1492. Okay, so we've done step 3. Let's go on to step 4. So step 4 then. If p-value is less than alpha, or alpha here in the question was 0.05. That's right. Write that down here. So alpha here, in our case, alpha is 0.05. Okay, and p-value our p-value is 0.1492. This implies that our p-value is greater than our alpha. So alpha value here. Okay, so when we have that situation, so hence we fail to reject the null hypothesis that here that 70% of people in Lancaster support issue X. There's still a chance that we are making a type 2 error. Okay, so let me talk a bit about the p-value a bit more here. Okay, so the p-value gives the probability of obtaining a test statistic at least as extreme as our observed z-score under the assumption that the null hypothesis is true. So let me go back to a picture so you can kind of see what's going on here. Okay, in my picture here, supposing the null hypothesis is this normal distribution with mean u here, and say I have 2 samples, x1 bar and x2 bar. So the p-value for x1 bar would be the area to the left of x1 here. It's because x1 is on the left of mu, so it's going to be the area to the left of x1. So p-value for x1 is area to the left of x1. And this sample mean over here, it was the right of mu. So the p-value for that will be the area to the right of x2 bar. So that's the idea. Let's keep going. So what our p-value is telling us here is that there is almost 50% here. It's almost 15% chance of making an observation like our sample that we got. So our sample was, let's see what was here. Oops. Up here. It was the X bar we had at the beginning. So so the probability of getting a sample like this, or more extreme, so more to the left of it, is about 15%. So it's a high enough chance. That's why we did not reject the null. We kept the null. So therefore, yeah, we keep the null here. So the sample does not suggest that we should reject the null. Okay, so we're done with question 1. Let's go on to question 2 now. Okay, so here's question 2. It says, boys of a certain age are known to have a mean weight of 85 pounds. A complaint is made that the boys living in a municipal children's home are underfed. As one bit of evidence, 30 boys of the same age are weighed and found to have a mean weight of 80.94 pounds. It is known that a population standard deviation sigma is 11.6 pounds. Use the z-test with level of significance 0.05 to decide whether the complaint has merit. Okay, so let's do our z-test. So let's paste our directions down here. Okay, so first we have to state the null and the alternative here. So the null would be, let's copy these here. So null would be then here that mu, or mu, so equals 85. So that means that they're not underfed, say, and our alternative guy here would be the are underfed, so that'd be the mean is less than 85. Okay, so that's step 1 done. Let's move on to step 2, calculate the z statistic. So let's do that. Okay, so the z-score is given by this. So in our case, we're given, going up here, we're given x bar is 80.94. Oops, go back there. So 80.94 for that guy. So that's 80.94. N is 30. That's our sample size. And the standard deviation, sorry, the sigma standard deviation is, where is it? 11.16. So that's our sigma. Move that guy down here. So our sigma, so our standard deviation equal this. Okay, so filling it up here. So let's just actually just take this, copy it, paste it here. Oops. Okay, so filling in these things in. So the n is 30. The x bar is 80.94. The mu, or mean, is it was 85 from the null right here. Okay, and our sigma is 11.6. Okay, so working this out, we get equals negative 1.917 and we're going to round that to 2 decimal places. So doing that is approximately equal to, so negative 1.92. Okay, so we're done with step 2 there. Now to calculate the p-value as follows. Let's see. So our null is greater than our alternative. Our alternative is less than 85. Our null is 85. So we have our null greater than alternative. So let's look at that case. So null greater than alternative. So it looks like case 2 here. So take away case 1 and take away case 3. So finding our p-value then will be probability probability z is less than our z-score, which is negative 1.92. Okay, so let's keep going. Okay, so now we have to look at our z-table, so right here. So looking at our z-table, we see our p-value. So we need to look at negative 1.92 on our z-table. Let's go to our z-table here. So 1.92 across here, up, so 1.92. So 1.9's here. Oh, there it is. And across, okay, let me draw on here. So negative 1.9. You go across, just out of the way, to 2 here. So it's like this guy here. So 0.0274. Okay, so let's clear this. So that was 0.0274. 0.0274. So that's saying the probability of observing a sample like the one we got was the 80.94. So that one, or to the left of it, the probability, there's only a 2.5% chance of observing something like that if the null hypothesis was true. Okay, so therefore it's not very likely to make an observation like ours if the null was true. So let's go on to step 4 now. Okay, so let's look at things here. So in our case, the alpha is 0.05, and our p-value we found is this guy up here, 0.0274. This implies our p-value is less than alpha. So this means then, hence we reject the null, and so our conclusion then would be the following. So hence we can say with 95% confidence that the boys are underfed. So underfed here. Note there's still a 5% chance that we're making a type 1 error. So here we're rejecting the null. So whenever you reject a null, there's a chance you're making a type 1 error. So we're done with this question. So let's do the last question in the next video.